Yes, sir.
Okay. Please write this question. Hello, Assalamu alaikum, Khalil. How are you?
Walaikum assalam, sir. I'm fine.
Okay. Write this question. And also, I just wanted to confirm that you will be preparing for NEET, right?
Yes, sir.
ठीक है. मेरा इरादा था कि लाइक जो भी नीट वाले हैं उनको एक बैच में कर ले, जो सीबीएसई वाले हैं उनको एक बैच में, जो जेई वाले, लेकिन अब आप लोग सारे के सारे इतने अलग अलग बैचेस में है ना, लाइक यू अटेंड लाइक मिक्स बैच है, केमिस्ट्री में भी मिक्स बैच है, बायो में, मैथ्स में, फिजिक्स में, सब में मिक्स बैचेस है ना. So it will be like very difficult to rearrange the students as per their own timing, है ना, जो भी उनका टाइमिंग का रिक्वायरमेंट है उसके हिसाब से रीअरेंज करना शायद डिफिकल्ट हो. सो व्हाट आई एम गोइंग टू डू, लाइक फ्रॉम नाउ ऑन दिस क्लास में हम नीट के सवाल भी लेते रहेंगे साथ साथ, ठीक है. नीट के सवाल, सो ऑब्वियसली लाइक नीट के सवाल जो होंगे दे विल बी एमसीक्यूज, है ना, उससे पता चल जाएगा, उसमें हम बता भी देंगे कि ये नीट के लेवल का है. जो सीबीएसई वाले हैं वो जब रिवीजन कर रहे हो तब उस टाइम, हाँ ये मतलब सीबीएसई वाले के दोनों के लिए है कि इफ यू आर रिवाइजिंग देन यू डोंट नीड टू रिवाइज दोज नीट क्वेश्चंस, है ना. You have to just revise the long form or problems type of question, जो word problem type का होता है. चलिए write this question. ठीक है, सबको समझ में आई बात? ये सर नो प्लीज टेल मी. यस समायरा,
Yes, sir.
नवाल, है ना. नीट वाले खास तौर से ध्यान देंगे, बाकी सीबीएसई वालों का क्या है, सीबीएसई वाले तो सीबीएसई का हो ही गए, चाहे नीट का हो नहीं. ओके. Nobody sends doubt and all, हाँ उनको हैरानी होती है आप लोग पढ़ भी रहे हैं या नहीं पढ़ रहे. अच्छा, सो दोस्त आर प्रिपेयरिंग फॉर नीट, है ना. समायरा, कैसे करते हैं आप प्रिपेयर? क्लास किया आपने, उसके बाद? यस समायरा,
Yes, sir. I revise.
यू रिवाइज, उसके बाद? हाँ समायरा, नेक्स्ट.
उसके बाद क्या?
उसके बाद फिर से क्लास. हाँ नहीं, ऐसे नहीं होगा ना. सी, दोस्त आर प्रिपेयरिंग फॉर नीट, दिस इज स्पेशली फॉर देम, ठीक है. सो you have to get a book that is previous year questions. Okay. Now, for a larger portion of my teaching career, I have seen Arihant book that has been like which has been used, है ना. But nowadays there is one book also by Disha publication. ठीक है. Now people are using this book also. Okay. So I still have the Arihant one, that is why I'm seeing Arihant. But you can also fetch for Disha one. ठीक है. So previous year question, and you should buy chapter wise, topic wise. Okay. Now, as you have said ना, हम स्टार्टिंग में या फिर बीच बीच में जो लेक्चर्स होते हैं उसमें हम बताते रहते हैं कि दिस चैप्टर हैज बीन लाइक यू कैन डिवाइड दिस चैप्टर इनटू दिस मेनी टॉपिक्स. तो कंसंट्रेशन टर्म, सॉल्युबिलिटी, वेपर प्रेशर, दीज आर द मेन टॉपिक्स, हेनरीज लॉ, है ना. तो ये सारे मेन टॉपिक्स हैं जिनमें आप डिस्ट्रीब्यूट कर सकते हैं. देन व्हेन यू गेट द प्रीवियस ईयर क्वेश्चन पेपर आफ्टर रिवाइजिंग वन, जैसे कंसंट्रेशन टर्म खत्म हो गया, देन यू विल डू ऑल द प्रीवियस ईयर क्वेश्चन दैट हैज बीन फ्रॉम द टॉपिक विच इज कंसंट्रेशन टर्म्स, है ना, इन सॉल्यूशन चैप्टर. उसके बाद फिर वेट कीजिए जब सिलेबस ये सारा खत्म हो जाए, देन यू विल गेट द टॉपिक सॉल्युबिलिटी के बारे में सवाल कीजिए. ठीक है. ये तो आपका हो गया, ये जो खुद से करना है, इसके लिए हम नहीं बोलेंगे आपको, है ना. दिस इज समथिंग दैट आई हैव टोल्ड यू वंस. अब इसके बाद आपको करना है चैप्टर वाइज, टॉपिक वाइज. उसके बाद जो डाउट्स होंगे वो आप हमको बताते जाइएगा. अब जिसके लिए हम आपको बार बार कहते रहेंगे वो क्या है, एक तो व्हेन द लेक्चर इज डन 5 to 15, this is for everyone, CBSE need 5 to 15 minutes before and 5 to 15 minutes after. ठीक है. And in this case you will use a highlighter. ठीक है. Take a highlighter ठीक है, टेक अ हाइलाइटर एंड हाईलाइट टेक्स्ट को मत कीजिएगा, ओनली द मेन हेडिंग्स एंड टॉपिक्स. ओके, main headings and topics, you will highlight those things. Okay, you will highlight those things and you will read also. Now this is 5 to 15 minutes, but next day आपको करना खास तौर से in this chapter, solution chapter, electrochemistry and chemical kinetics, you have to redo all the questions of lecture without looking, okay, without looking at the answers, without looking at the solution, without even reading the solution, I would say initially. या फिर you just read it once, then if you read it once, then you have to solve it half an hour later. Okay, you have to solve it half an hour later, or else what you can do, you can start and revise. जब कर रहे हैं तो रिवाइज करते हुए आपने इसको पढ़ लिया एक बार, फिर शाम में आप उसको देखने के लिए बैठे. ऐसे नहीं कि एक बार देखा फिर उसके बाद फिर से ट्राई कर रहे हैं, फिर एक बार देखा फिर ट्राई कर रहे हैं. So that will only give you the illusion that you have the knowledge of how to solve the question. You won't be able to solve the question. Okay, so whenever you are reading something, like for example, take a half an hour or 1 hour gap and then try to solve that question. Okay, redo all the question of lecture without looking. ठीक है, अब इसके लिए तो आप खुद ही जिम्मेदार है ना. यू विल बी ऑनेस्ट विथ योरसेल्फ कि आपको आता है कि नहीं आता है. ठीक है, एंड अच्छा, रीडू ऑल द क्वेश्चंस, दैट इज इट. ओके, एंड द असाइनमेंट्स, एंड असाइनमेंट्स विल बी देयर. ठीक है, आपकी क्लासेस होती है ट्यूसडे एंड थर्सडे. ठीक है, ट्यूसडे एंड थर्सडे. अच्छा, वन मोर थिंग दैट आई विल आस्क यू गाइस, व्हिच इज आई डोंट नो, पता नहीं कितना ये चीज चलता है मिडिल ईस्ट में या नहीं चलता है. जो दोस हु आर प्रिपेयरिंग फॉर नीट, especially for them, you have 6 days at school. 6 दिन होते हैं classes?
No, so 5 days.
5 days only?
Yes.
अच्छा, so you holiday on Friday and Saturday?
Yes, sir.
Okay, fine. Friday, Saturday holiday होता है, यानी कि you have time है ना. So you can dedicate at Friday का. Friday आप ये कर लीजिए कि like before lunch है ना, and try to wake up at like when you are preparing for something, फिर आराम नहीं है आपके लिए. ओके, और स्पीक बहुत ही हम हल्के में बोल रहे हैं, बट आई होप यू ऑल नो हाउ पीपल प्रिपेयर फॉर नीट एग्जामिनेशन एंड जेईई एग्जामिनेशंस इन इंडिया, राइट. सो उसमें आपको सोना और आराम वो सब चीजें नहीं है आपके बिल्कुल प्रायोरिटी लिस्ट में. यू हैव योर सिलेबस दैट इज इन योर प्रायोरिटी लिस्ट एंड यू हैव अ पर्टिकुलर थिंग्स दैट यू हैव टू डू इन ऑर्डर टू कंप्लीट दैट सिलेबस. दैट इज योर प्रायोरिटी लिस्ट. नहीं सोए आप, है ना, रात में आप गए 10 बजे, नींद नहीं आया, 2 बज गया, 3 बज गया, नींद नहीं आया आपको, है ना, लेकिन सुबह 7 बजे उठ के आपको करना है ना. सुबह 7 बजे उठ के आपको, नाउ यू फिक्स द टाइमिंग्स लाइक फॉर फ्राइडे, इफ यू इवन डू 7 to 1, नो, सो हाउ मेनी आवर्स इज 7 to 1? 7 to 1 हाउ मेनी आवर्स बताइए? 7 AM to 1 PM, घंटा 6 hours है ना. So you have 6 hours. Now in this 6 hours you can dedicate 2 hours to each subjects. You will have just 3 subjects, right? Now in this 2 hour, what you will be doing, you will be revising. In these 2 hour you will be revising for whole week. Okay, whatever has been done from Saturday to Thursday, you will revise, है ना. अभी स्कूल का या फिर कोचिंग का आप देख लीजिए जिसमें आपको जो भी प्रेफरेंस है. Okay, so I will suggest that you revise everything that has been taught in the coaching, not in the school. Also, जिनके भी 6 दिन क्लासेस होते हैं, प्लीज एक दिन स्कूल मत जाइए. ओके, एंड फॉर एग्जांपल लेट अस से दैट सॉल्यूशन चैप्टर खत्म हो रहा है कोचिंग में, लेकिन आपने असाइनमेंट नहीं किए हैं, आपने एनसीईआरटी का टेक्स्ट बुक कंप्लीट नहीं किया है, तो फिर आप एब्सेंट कीजिए एक दिन स्कूल से. लाइक प्लीज रिमेंबर, योर स्कूल शुड टेक अ लॉस, नॉट द प्रिपरेशन दैट यू आर डूइंग. ठीक है, योर स्कूल शुड टेक द लॉस. इज दैट फाइन? यस और नो? सबको समझ में आया?
Yes, sir.
जर्श अभी जा रही है एएमयू, है ना, अलीगढ़ में उनका हो गया है. देयर शी विल सी लाइक हाउ द पीपल दे प्रिपेयर, फिर उनको वहां से मोटिवेशन मिलेगा. आई डोंट नो मिडिल ईस्ट में रह के पता नहीं किसको कितना मोटिवेशन मिलता है जेईई और नीट के लिए.
जीरो मोटिवेशन होता है मिडिल ईस्ट में सर.
जीरो मोटिवेशन होता है ना. एक तो सऊदी लोग को देख देख के आप लोग को और लगता होगा इनका सही है, आराम से बस बैठे ही रहते हैं. लाइक दे आर the whole situation when you land in Saudi airport from Indian airport, it is like हालात बदल गए, जज्बात बदल गए, right? Everyone is very relaxed and everyone is very chill. I understand that whole environment is not very hustle type, but JEE and NEET, it requires, yeah, obviously hard work तो है ही, लेकिन correct orientation भी जरूरी है, that you orient yourself in a right direction, है ना. ऐसा नहीं कि आप किसी चीज में जा रहे हैं प्रीवियस ईयर के बाद आप फिर उसके बाद, जैसे फिजिक्स में होता है, फिजिक्स में लोगों को बहुत टफ टफ किताबें पता रहती है, केमिस्ट्री में लोग बताते भी नहीं है. फिजिक्स में जैसे रेसनिक हॉलिडे एक किताब है, राइट, HC वर्मा है, दैट यू हैव टू डू ऑब्वियसली. इवन इफ यू आर प्रिपेयरिंग फॉर नीट, आई विल सजेस्ट दैट डू HC वर्मा. ना हम नहीं होते, फिर आप फिजिक्स टीचर से पूछिएगा, अपने ज्यादा बेहतर बताएंगे, है ना, नाउअडेज क्या चल रहा है. देन देयर इज वन मोर बुक इन ये फिजिक्स, डू यू नो दैट बुक, जो उससे भी हार्ड होता है, HC वर्मा से भी ऊपर. देयर इज HC वर्मा एंड थ्योरी के लिए रेसनिक हॉलिडे एक किताब है. हाँ, आई रोडोफ का नाम सुना है आप लोगों ने, किसी ने? आई रोडोफ.
Yes, sir.
So आई रोडोफ इज वन अनदर बुक, लेकिन उतना डीप जाने की जरूरत नहीं रहती है. इफ यू डू वन बुक with like you, if you complete each and every question of HC Verma, that will be fine in order to clear the concepts in physics, है ना. केमिस्ट्री में उतना कुछ जरूरत नहीं रहता. केमिस्ट्री में you have just the NCERT, वो खत्म होना ही होना है, उसके बाद ही आप आगे बढ़ सकते हो. And then the previous year questions for NEET and all, that will be enough. Okay. और ये है कि हाँ, like for example JEE में जो कुछ सवाल आते हैं, नीट में थोड़ा सा जो लेवल रहता है JEE एडवांस से थोड़ा सा कम रहता है, JEE मेंस के बराबर टाइप का रहता है. तो you can also see those questions from JEE, those questions from JEE which are not having much calculation and all. नीट में ज्यादातर उस तरह के सवाल आते हैं ना, where you don't need much calculation. So those things वो भी आप कर सकते हैं. खैर, so कितने से हुआ ये सवाल? एक सेकंड, है ना. Okay, sorry for that. चलिए, so let us see this question. किसी से हुआ ये सवाल? अच्छा, let me give you an idea what the question is telling. A solution of A and B with A and B. So we have solution of A and B. These are the components with 30 mole percentage. With 30 mole percentage, A is in equilibrium with its vapor. So we have a solution of A and B, and in that we have 30 mole percentage. We have 30 mole percentage of A. So देखिए, जो आपका solution है, the solution that we are having, which is liquid, okay, this liquid solution, it is having 30 mole percentage of A, है ना. If you have 30 mole percentage of A, then B will be 70 mole percentage. Yes or no? Please tell me.
Yes.
है ना, A और B ही है बस. Okay, now see the next line. Next line is its vapor which contains. Now it's vapor, so we will have solution, and just above it we will have its vapor, right? Just above it we will have its vapor. It's vapor which contains 40 mole percentage of B. So we have vapor. Now vapor is what? Vapor is what? This is gases, okay? These are all gases. So vapor is if 40 mole percentage of B, यानी कि 60 mole percentage of A is there, and we have 40 mole percentage of B. Is that right? Yes or no? Please tell me.
Yes.
Correct? Okay. Now 30 mole percentage of A, that means we can write. That means we can write the chi A is equal to 0.3. Yes or no? बात समझ में आई सबको? And chi B will be equal to 0.7. नहीं आया किसी को. Can I write like this? Number of moles of A is equal to 3. Then the number of moles of B will be equal to 7. ये लिख सकते हैं? All of you agree with this? Yes or no? Please tell me.
Yes, sir.
Yes, na? Okay, now सी अब देखिए मोल फ्रैक्शन की अगर हम बात करेंगे, मोल फ्रैक्शन की बात करेंगे तो काई ए विल बी इक्वल टू हाउ मच? काई विल बी इक्वल टू नंबर ऑफ मोल्स ऑफ ए, दैट इज 3/3 plus 7 which will be equal to 3/10 which will be equal to 0.3. yes or no?
Yes.
सही है ना? तो अब देख लीजिए काई कितना हो जाएगा 0.3 एंड हाउ विल बी गेटिंग काई बी इज इक्वल टू 0.7. ठीक है. नाउ सिमिलरली हियर, अब यहाँ पे तो हम डायरेक्ट लिख सकते हैं, आई थिंक ऑल ऑफ यू विल एग्री दैट वाई ए, now what is y? Y is again the mole fraction, but it is for vapor, that is why we are using the word y. Okay, it will be equal to 0.6 and yb will be equal to how much? It will be equal to 0.4. Is that right? Yes or no? Please tell me.
Yes.
Okay, now assuming that the solution and vapor behave ideally, calculate the ratio of vapor pressure of pure A and pure B. Now assuming the solution and the vapor behave ideally का मतलब क्या? They will follow the Raoult's law. Yes or no? Ideal solution follows Raoult's law. Yes or no?
Yes.
Okay, each and every line in the question, it has some meaning and it has some importance. And the solution behave ideally. Okay, behave ideally. So this is telling me that we have to use the Raoult's law. So according to Raoult's law, we have P total is equal to P naught A chi A plus P naught B chi B. Okay, P naught B chi B. Okay. Now, if you remember one of the questions that we did in the last class, y of A will be equal to P of A upon P total. Yes or no? Tell me. You remember this?
Yes, sir.
Yes, sir.
Right. Okay. Now, P of A, what I can write for P of A? I can write it is P naught A chi A upon P total. Yes or no? Tell me. According to Raoult's law, P is equal to P naught A chi A, na? Correct, all of you?
Yes.
Now we can also write YB is equal to P naught B chi B upon P total. Yes or no?
Yes, sir.
Okay. Now see what is the question they're asking. They're asking, see each and every line, each and every line. They're asking calculate the ratio of vapor pressure of pure A and pure B. ठीक है? Vapor pressure of pure A and pure B. Ratio of यानी once you will have numerator and denominator. Numerator में vapor pressure of pure A and vapor pressure of pure B. So I hope you can easily see that we can have the vapor pressure of pure A as P naught A and pure B is P naught B. So we will be using these two equations. Okay, we will be using these two equations. So now we will divide YA upon YB. So YA upon YB. This will be equal to what? This will be equal to P naught A chi A upon P total divided by P naught B chi B divided by P total. Okay. Now we can eliminate P total because for both of them the P total will be equal to P naught A chi A plus P naught B chi B. Okay. Now we will write this as YA upon YB is equal to P naught A upon P naught B into chi A upon chi B. Okay. Now furthermore what we can write? P naught A upon P naught B क्या हो जाएगा आपका? प्योर जो P naught A upon P naught B, it will be equal to YA into chi B upon YB into chi A, है ना? So this will be equal to what is YA? YA कितना कैलकुलेट किया हम लोगों ने? YA और chi B देख लेते हैं बस. YE 0.6 into 0.7, 0.6 into 0.7. तो YB कितना हो जाएगा? 0.4. YA कितना XA हो जाएगा? chi A हो जाएगा आपका 0.3. Okay. So I hope we can write from here that this is how much? 2 is up, right? So this will be equal to, okay, now we can also eliminate these two. So this will be by 0.2, है ना? So you will get this as 0.7 upon 0.7 upon 0.2, which will be equal to 7 by 2, which will be equal to 3.5. So you can write the ratio of vapor pressure of pure A and pure B is equal to 3.5 है ना. चलिए, I hope this question was easy है ना. Not all, see, the calculation is not much. You have to just apply a simple. Whenever you get ratio type of question, ratio इन दोनों के बीच में क्या होगा, तो please remember एक इस तरह का फॉर्मेट के सवाल में हमेशा you will have one equation, you will have another equation, and in that you will be dividing the first equation by two equation, है ना. तो इस तरह का दिमाग में हमेशा रखिए. Whenever you are getting ratio, you will be getting two equation and you have to divide them, and you have to divide them. चलिए, please write this down. लास्ट टाइम में हम लोगों ने क्या किया था आइडियल नॉन आइडियल में, एक सेकंड. हाँ, अच्छा, आइडियल नॉन आइडियल इज डन ना. सो वी हैव टू डू टाइप्स ऑफ नॉन आइडियल सॉल्यूशन. ठीक है, चलिए, टाइप्स ऑफ नॉन आइडियल, पॉजिटिव डेविएशन, नेगेटिव डेविएशन. उसके बाद एजियोट्रोप भी खत्म कर देना. हाँ, एजियोट्रोप हो जाएगा खत्म. आज एक सपोज टू हैव अ न्यू किड, बट वो तो है ही नहीं.
So there's a ratio, right? So we could write 7:2 or 0.7.
हाँ, we can write 7:2. हाँ, वो भी लिख सकते हैं. Actually, like, since we have talked about ratio, so whenever the ratio is used now, so ratio tells, like, ratio will tell you about how much of a particular thing there is to compare to another one, है ना. So you are comparing two things. So generally we compare it like this, ना, like it is 3.5 more times, या double है उससे या फिर triple है उससे. That is why P naught of A upon P naught of B, if I say it is equal to 3.5, no, so it is giving me a better idea that P naught A is 3.5 times of P naught B. Got it?
Yes, sir.
Yes. So who was asking? Khalil or Matthew? Who was asking about this?
Yes, sir.
Matthew, no? So Matthew, you understood the reason why 3.5?
Yes, sir. Yes, sir. Understood.
So 7/2 will not be giving me that much clear idea, है ना? That is why 3.5.
Okay, sir.
Done all of you? Yes or no? Please tell me.
Yes, sir.
So let us write the next topic. Types of non-ideal solutions. Types of non-ideal solutions. Okay. So in this we have number one, which is the solution which show positive deviation from Rolle's law. Now, secondly, there are some which will show negative deviation from Rolle's law. Okay, negative deviation from Rolle's law. In this case, we will be first of all looking at solution which show positive deviation from Rolle's law. Okay, positive deviation from Rolle's law. Now, if you remember positive deviation from Rolle's law, we have explained this thing, yes or no? Please tell me now.
Yes,
Did we
sir.
explain this? We explained these things, na?
Which one? Deviations?
Deviations, huh? नहीं. Okay, so basically,
I think we did this.
We did this,
Kind
right?
of.
Explain it.
Yeah, kind of. Yeah,
Right.
yeah. You just
If you remember
told us
last
an
class,
idea.
so there can be two type of deviations if you see Rolle's law, right? The pressure total that is measured, this is measured. It can be greater than the calculated one, or it can be less than the calculated one. So if it is greater than the calculated one, it is known as positive deviation from Rolle's law. If it is less than, then it is known as negative deviation from Rolle's law. Is this clear? Yes or no? Please tell me, guys.
Yes, sir.
Anna. So when we have positive deviation from Rolle's law, in that case, what is going to happen? Positive deviation from Rolle's law, what is going to happen from here? In this case, the P total will be greater than P naught A chi A plus P naught B chi B. And this can only happen if the PA is greater than P naught A chi A and the pressure due to B is greater than P naught B chi B. Okay, P naught B chi B. Now what we will do, we will look at one of the example for positive deviation. We will look at one of the examples for positive deviation in Rolle's law, and after that we will also explain some of the reasons for this type of deviation. Okay, some of the reasons for this type of deviation. Now the example that we will look at is, okay, what is the example? The example is, if you have ethanol, ना अब मत लिखिएगा इथेनॉल इसके बाद, ठीक है? इथेनॉल प्लस साइक्लोहेक्सेन. Okay, ethanol plus cyclohexane. So if you now don't write, okay, after this don't write, please don't write, leave your pen aside. Ethanol, the formula for ethanol is C2H5OH, and the formula for cyclohexane will be equal to how much? Okay, this will be the structure. This will be the structure. Each of these carbons, they will be having 2 hydrogens, so there are 6 carbons, so there will be C6H12 is the formula, C6H12. Now one thing you can very easily see that here we are having a hydrogen bond due to OH, right? There is this OH, which is the hydrogen bonding, and it will have hydrogen bonding. Individually speaking, C2H5 will have hydrogen bonding. If you have a solution, sorry, if you have a container in which you have ethanol, it's all the molecules inside that, each and every molecule of ethanol will be connected through, will be having some kind of hydrogen bonding. But if I look at cyclohexane, so cyclohexane is what? It is non-polar, right? It is non-polar. That is why it will just have dispersion forces or London forces. Only London forces is there, right? So now you tell me, if I compare hydrogen bonding and London forces, which is having higher or greater attraction, greater force of attraction will be in hydrogen bonding or London forces? Tell me. States of matter कुछ याद नहीं. Hydrogen bonding, भाई, hydrogen bonding will be having higher intermolecular forces of attraction. Higher intermolecular, yes, correct. Okay. Now, if hydrogen bonding is having higher intermolecular force of attraction, now what we are going to do? We are going to mix them. Not why. What we are going to do? We are going to mix them. Now, initially, what is happening? Initially, each and every ethanol is having some kind of hydrogen bonding. So if each and every ethanol molecule is having hydrogen bonding, the attraction is higher. The vapor pressure will be lower. But as soon as I add cyclohexane, then cyclohexane will be occupying some space between ethanol molecules, and that is why the number of hydrogen bonding will decrease as we increase the number of cyclohexane molecules. Yes or no? If I increase this, then the hydrogen bonding will decrease because it will occupy some space. And if it is occupying space between ethanol molecules, it will be disturbing the hydrogen bonding. Yes or no? All of you understood this point? Okay, very good. Now, once you have understood this point, we know that now we have less hydrogen bonding. When we mix this, what will happen? We will see a decrease in hydrogen bonding. If we see a decrease in hydrogen bonding, then we can say what? We can say that molecules will escape easily. Yes or no? They will escape easily or not easily? Escape easily or not easily? Bataiye. If the intermolecular easily. Escape easily. Very good. Escape easily. If they are escaping easily, there will be more vapor pressure, less vapor pressure. More vapor. Yes, na? There will be, if they are escaping easily, there will be more vapor and there will be more vapor pressure. Correct? Yes or no, guys? What happened?
Yes,
sir.
Yes, sir. बोलिए ना, yes sir बोलिए, कैसे समझ में आएगा कि आपको समझ में आया कि नहीं आया? ठीक है. अब there is more vapor pressure. That is why positive deviation. Okay. So now you can start writing. Okay. Now you can start writing. What will you write here? What will you write? So you will write here. After the mixing, the extent of hydrogen bonding decreases. Extent of hydrogen bonding decreases, है ना? And if that that is intermolecular forces of attraction decreases, है ना? This will increase. There will be increase in vapors, and there will be increase in vapor pressure also. There will be increase in vapor pressure. Okay, there will be increase in vapor pressure, and that is why we can say that the P total will be greater than P naught A chi A plus P naught B chi B. Now, tell me, please tell me. थोड़ी देर के लिए पॉज कर लीजिए आप लोग, हाथों को बताइए. If the intermolecular forces of attraction has decreased, the volume will increase or decrease. If the attraction is lower, तो ज़्यादा जगह ऑक्यूपाई करेंगे, it will increase. That means volume after mixing, volume final, will be greater than volume initial. Is that clear? Yes or no? Zarsh, Nawal, आप लोग बताइए, new students.
Yes, sir.
Yes, है ना? अगर attraction lower हो गया, दूर दूर है तो ज़्यादा volume. Okay, that is why we can also say the change in volume will be positive. Now the volume will increase, or you can also say the delta V is greater than 0. सब सही लिखा दिया हमने. ठीक है. Now, अब यहाँ पे फिर से आप लोग सुनिए एक बात, ठीक है? Also listen one more thing. We have AB. इनिशियली तो AA है हमारे पास, ethanol plus BB, and it is going to give me AB plus AB. Okay, AB plus AB. Now, in order to go from initial to final, that means in order to go from components, individual components to the solution, we have to break the force of attraction between, AA. You have to break these, and we will be forming these. Yes or no? Please tell me.
yes,
That means if I am breaking something, there will be some energy required for that. And if I am forming something, now in like it will depend on the extent of the attraction between A and B. I will be releasing some energy, right? I will be releasing some energy when I am forming AB. So whenever the bonds are broken, whenever any attractive forces is broken, energy is required. You have to give energy. And whenever attractive forces are formed, then what is happening? Then the energy is released. Now we obviously know that the formation is what? The intermolecular forces of attraction, these are not having a high magnitude. These are having less magnitude than the initial one. These are having this magnitude. If these are having less magnitude, that means they will be releasing less energy. And that is why we can say that we will be requiring more energy here, right? So energy required, right? Energy will be required and less energy will be released. So you'll be requiring more and more energy in order to break this bond. If you are requiring more and more energy, that means what we can say, the process of mixing, is endothermic. You can write delta H will be equal to positive, or you can also write delta H will be greater than 0. So both the things are greater than 0 here. Okay. Clear is up? Yes or no? Please tell me. Is this clear, guys? Yes or no?
Yes, sir.
All of you wrote this? Yes or no? Please tell me.
Yes, sir.
Yes,
Okay.
sir.
Now we'll draw the graph for the positive deviation. Okay. Graph for positive deviation. अब इसके लिए हम क्या करेंगे? I will just borrow the graph for Rod's law, and then.
Sir, could you show the last point again?
अरे हमने तो scroll कर दिया ना. Wait a second. So Rod's law is a special case. Wait a second, huh? ये लिख लीजिए last point. Delta H. Now wait a second. In the subscript, you will write delta H mixing. Okay. Delta H mix subscript में लिख लीजिए उसके. Okay. Should we explain the graph for positive deviation? Yes or no? Please tell me. All of you done now? Okay. Listen, everyone. So see, we all know that all of these straight lines, these will be for the ideal situation. And we also know that in the non-ideal situation, that is for positive deviation. In positive deviation, what is happening? The P total. So this line is representing what? P total. We all know the P total will be greater than the ideal, right? Greater than the calculated. So all of these straight lines, you can say that these are giving you an idea about the calculated P total, and the original or the measured P total will be a bit higher. So it will be like this. Okay, it will be like this. Now, when I look at, wait a second, both will be higher only, no? This is P naught A chi A plus P naught B chi B, which is the calculated, and this line, it represents P total, which is measured. Okay, this line represents P total, which is measured. Okay. Now, similarly, PA will be higher. PA will also be higher than the calculated one, and your P naught B will also be higher than the calculated one. Okay, so the graph will be like this. So all the straight line, they are showing ideal behavior. Whenever you have the curved line, that is the positive deviation from Rod's law. Okay, please make this graph. Then write the topic explanation for negative deviation. Or you can just write negative deviation. Wait a second, कैसे हम लोगों ने topic लिखा है? Negative deviation, second point. अच्छा. Do you have people or do you know your juniors यहाँ पे? Is there anyone who knows their juniors? Khalid, Salman, you
Yeah, I
guys?
know a lot. Yeah.
You know a lot? Now, उनका 10th अभी खत्म हुआ होगा, right?
Yeah.
Yes or no?
Just right now. Yeah.
Just right, just now. Now, just suggest them if they want to join any coaching, okay? Whether it is Learnivio or if they are like considering tuitions or coaching, then tell them to join as soon as possible. Okay? I hope you all have the experience, right? Khalid and Salman, क्या होता है अगर आप बहुत लेट ज्वाइन करें?
Yes, sir. We do.
Yes, है ना? So ये तो जरूर ट्राई करने बोलिए कि गर्मी छुट्टी से पहले कर ले, है ना? And it is good that you guys have the summer vacation like it is in July and August, right? July, August is your summer vacation, Middle East, में,
Yeah,
right?
around that time.
है
Yeah.
ना? So just ask them to join like in June at least. So they will have at least 1 month. Okay, they will have 1 month in which they can get an idea कि कितनी मेहनत करनी पड़ेगी, so that they can do some more. They can put more efforts in the summer vacations also. Okay, तो उसकी वजह से they will be ahead of the school syllabus. चलिए. I hope everyone has written this. Yes or no? Graph for positive deviation.
Yes.
Okay. Negative deviation from Rolls.
Sir,
I think we will
sir,
take. Okay. हाँ ठीक. सलमान will be like, सर आप तो बात करने लगते हैं, लिखेंगे.
Yeah. Okay, sir.
चलिए. So we'll take an example. Okay. Now example here is for acetone and chloroform. Acetone and chloroform. Now acetone and chloroform, both of these are, you have to remember the structure. So acetone is carbon with a double bond, O, which has two CH3 groups. Okay. Chloroform is, there will be a hydrogen and the other three will be chlorines. Okay, so this is chloroform. If I look individually, then I can say that this molecule is polar because it is having delta negative here, delta positive here, right? So this will be polar. This molecule is polar, individually speaking. Okay, this is all before mixing. And this molecule will also be polar because, as you can see, that these chlorine molecules, they will be attracting, right? They will be attracting the electrons from carbon, and then this carbon will become delta positive. When it is delta positive, it will be attracting more electrons from hydrogen because hydrogen is less electronegative, right? So this hydrogen will become very highly delta positive, Okay, so three chlorines are there. Right? Just imagine that three chlorines is attached on carbon, and then all the three chlorines are pulling electrons from carbon, and eventually carbon is pulling electrons from hydrogen also. So there will be delta positive. Here also you will see that there is a polarity, and that is why this will be also polar molecule. So now both of these are what? Both of these are polar. But as soon as we will mix them, so if we are going to mix these two, then you will see that this delta negative, and also there are lone pairs here, right? There are lone pairs, and it is very highly delta positive. So you have here electron source, there is electron sink, and this is why there is a creation of hydrogen bond, right? If you have interaction between oxygen and hydrogen, then it is hydrogen bond. And see, this oxygen will not form hydrogen bonding with this carbon atoms. Why? Because this hydrogen atoms, because these hydrogen atoms does not have the appropriate amount of positive charge. But since this hydrogen is connected to carbon, which is further connected to three chlorine atoms, that is why this is having appropriate positive charge, and this positive charge is interacting with the negative charge of the partial negative charge of oxygen, and it is forming hydrogen bonding. If they are forming hydrogen bonding, then after mixing, what will happen? IMF, intermolecular force of attraction, it will increase. If the intermolecular forces of attraction will increase, then I hope you all know what will happen. Less and less gas will be formed. If less and less vapors are formed, then the vapor pressure will also be low, right? The molecules, they will not escape easily, right? Intermolecular force of attraction is higher, escape is lower, which will give me vapor pressure, which is also lower. Okay, so we can write here. What we will write? Hydrogen bond is formed between oxygen of acetone and hydrogen of chloroform after mixing. This type of hydrogen bond is not present. Is not present where? Is not present in any component, in any of the component individually. Okay, individually. Next, what is happening? As intermolecular forces of attraction will increase, vapor pressure will decrease, right? So P total will be less than the calculated one, P naught A chi A plus P naught B chi B. Next thing that we can write, the change in volume will be, क्या होगा बताइए? V final V initial को अगर हम compare करें, so V final will be smaller than V initial because V final has more and more attractive forces. If the forces of attraction is higher, then what will happen? It will take lesser volume. So V final will be less than V initial, and that is why delta V will be negative, or we can write delta V is less than 0. Okay. Furthermore, we can also write now, since there is more force of attraction in the final, right? After mixing, we have more force of attraction, so more and more energy will be released. That's why it will be exothermic. The process will be exothermic. That means delta H of mixing, it will be negative. Okay? It will be negative whenever there is a process which is exothermic. The enthalpy is negative, and we can also write delta H of mixing, it will be less than 0. Chaliye, please write this down. Please write this down. Let me know when you are done. सबको समझ में आया? Yes or no, please tell me. All of you got these points, na?
Yes, sir.
Yes, sir.
Okay. Why did you hit it very hard, Salman?
I was doing something and then I hit it.
Like वो गलती था या फिर जानबूझ के?
No, by mistake. Why would I hit it?
I don't know. I don't know. You can though. I mean, not you. One can. One can. Na? Possibilities are there.
Yeah, but no.
ध्यान से बोल दीजिएगा आप लोग, खालिद, सलमान एंड whoever, if you have any juniors ना, जो आपको पता हो, please let them know that they should start the 11th standard. That means 11th standard chemistry or any subject like 11th standard का physics, chemistry, math, bio जो भी ले रहे हैं, जितना जल्दी से जल्दी हो सके, they should join a tuition or something if they are planning. If they are not planning to, that means उनको एक बार experience करना है. How does it feel to be completely confused in a class, right? So after they will experience that, then उनको होश आएगा, नहीं भाई कर लेते join, है ना? After that they will join. फिर आप लोग क्या कीजिएगा? फिर आप लोग को बोलने का ही मौका, हम तो बोले ही थे तुमको ज्वाइन कर लो. There is one dialogue, I don't know which. Has anyone here seen Mirzapur? You should not see Mirzapur, but still, have anyone? Is there anyone who has seen Mirzapur? Hey, you can say. हम नहीं डांटेंगे. Okay, fine. सब अच्छे बच्चे किसी ने नहीं देखा. Okay. There is one dialogue. हमको ज्वाइन कर लो. Okay. Done all of you? Yes or no? Please tell me. हुआ? नहीं हुआ? Done ना?
Yes, sir.
Okay, चलिए. Now what we will see? We will see the plot for graph for. Look at the graph for negative deviation. Okay. So let us. Achha, again we have to borrow something from here. Let's take this thing. Okay. Now in here, the only change will be that. The only change will be all the pressure, vapor pressure will be what? Negative deviation. That means it will be low, right? So you'll be drawing it like this. The vapor pressure, the measured vapor pressure is low. The measured vapor pressure is low, and the measured vapor pressure is low. Okay. So you draw this graph. अच्छा, आपके बैच में do you know of any student in your school या फिर not also in your school those who make digital notes, like they have an iPad and all, उसमें notes बनाते हैं? Is there anyone who knows someone like that?
I don't know, but I do sometimes.
नहीं, sometimes नहीं, like उनका notes वही होता है, like iPad में ही notes बनाते हैं और कहीं नहीं बनाते. No, okay. Done all of you? Yes or no? Please tell me. All of you done na, yes or no?
Yes, sir.
Yes.
Okay.
Yes, sir.
They write this question. So this topic, it has like very easy questions. Okay. So, the mixture which shows positive deviation. बताइए कौन सा होगा? We have done some examples ना, उससे आप ये करके बताइए, relate करके. Send the answers in chat है ना? You have done the examples, right? Examples को देख के relate करके बताइए. Which one of them will show positive deviation from Rolle's law? अच्छा, one thing, please tell me. जो भी हम लोगों ने पॉजिटिव डेविएशन नेगेटिव डेविएशन देखा था, दैट वाज ऑन द बेसिस ऑफ इंटरमॉलिक्यूलर फोर्स ऑफ अट्रैक्शन, राइट? तो उसको लेके चलिए. लाइक इफ यू लुक इन द पॉजिटिव डेविएशन नेगेटिव डेविएशन, पहले क्या किया हमने? इंडिविजुअल का फोर्स ऑफ अट्रैक्शन है, लाइक व्हाट विल बी द फोर्स ऑफ अट्रैक्शन इन इथेनॉल, व्हाट विल बी द फोर्स ऑफ अट्रैक्शन इन साइक्लोहेक्सेन. उसके बाद मिक्स करने पे क्या होने वाला है? ओके, सो प्लीज सी दिस एंड टेल मी. फॉर ईच एंड एवरीवन आई विल आस्क. ठीक है, बेंजीन में क्या है इंटरमॉलिक्यूलर फोर्स ऑफ अट्रैक्शन, उसको ध्यान में रख के आपको आंसर दीजिए. ठीक है, कोई भी आंसर मत दे दीजिए. चलिए, सो टेल मी, प्लीज टर्न द माइक ऑन एंड टेल मी. अच्छा, हु हैज आंसर्ड? हम उन्हीं लोग से पूछते हैं.
C.
हाँ, वाह 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 वाह. क्यों सी भाई? अच्छा, जो भी बोल रहे हैं ना, वाई सी? टेल मी, क्लोरोईथेन में कौन सा ये है? व्हाट इज इंटरमॉलिक्यूलर फोर्स ऑफ अट्रैक्शन इन क्लोरोमीथेन?
Sorry, D.
वाई. अच्छा, चलिए, इथेनॉल में कौन सा है? डी 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 डी. आनिया ने भी चेंज कर दिया. ये सी क्यों कह रहे थे समायरा? व्हाई पीपल आर सेइंग सी? Okay, listen here. Benzene and toluene, non-polar plus non-polar. ठीक है, non-polar plus non-polar, it will give you non-polar only molecules, है ना? और उसके बाद if you see benzene and toluene ना, आपको अगर याद करें तो आइडियल क्या है, इसमें हमने दिखाया था आप लोगों को. This was one of the examples for ideal solution. करना नहीं रहता है. देखिए, example benzene toluene, and I said that one, then एक कार्बन का डिफरेंस होगा तो दोनों, that will be obviously ideal solution. See here, characteristics of ideal solution, in that we have given example benzene and toluene. तो ये तो भाई एकदम ही नहीं होना चाहिए. ठीक है, नॉन पोलर, खत्म बात. Acetone and chloroform. Acetone is also polar and this is also polar. So polar and polar, they will make you what? They are going to give you polar molecule only. Okay, they are going to give you पोलर मॉलिक्यूल. अच्छा, दूसरी बात, एसीटोन और क्लोरोफॉर्म को जब हम करते हैं तो क्या देता है हमको? नेगेटिव डेविएशन देता है भाई.
Yes.
ठीक है, जर्श जर्श
Yes, sir.
कैसे आपने लिख दिया यहाँ पे? बी आंसर होगा. ठीक है, सो दिस इज एग्जांपल इज आल्सो ऑलरेडी देयर इन योर नोटबुक. दिस इज आल्सो एन एग्जांपल व्हिच इज ऑलरेडी देयर इन योर नोटबुक. ठीक है, अब ये बताइए, ये भी आपके नोटबुक में है कि नहीं है? क्लोरोईथेन ब्रोमोईथेन, क्लोरोईथेन ब्रोमोईथेन आर व्हाट? आइडियल. ठीक है, ये तीनों तो मतलब दीज आर, सी, ये तीनों आपके टेक्स्ट बुक में है ना? मतलब मेरे नोटबुक में, यानी कि हमने टेक्स्ट बुक से ही तो पढ़ा रहे हैं हम किसी, है ना? तो ऑल ऑफ दीज आर व्हाट? दीज आर टेक्स्ट बुक एग्जांपल्स. ठीक है, दीज आर टेक्स्ट बुक एग्जांपल. So there are two ways in which you can answer this question. Why the NEET में आया 2020 में है ना, they have put this question. Why? Because all of these three are textbook questions. So even if you have read the textbook, then you can take that. You can take that all of these options are wrong. This is the only option which can be correct, which can show the positive deviation. Okay. If you remember the concept, then from concept you can remember that ethanol is C2H5 OH, and acetone will be what? Acetone will be, what will be acetone? C double bond O, right? Now you tell me here. We have one is showing what? One is showing hydrogen bonding, and the other is showing, what is the other one showing? What is the other one showing? This is showing hydrogen bonding. This is showing delta positive, delta negative. ये सारी चीजें हमने लिखा है यहाँ पर, नहीं जवाब है. Polar, right?
Yeah.
These are polar. Dipole moment is, these are polar interactions. यहाँ पे है hydrogen bonding. So if you have hydrogen bonding, which is obviously more, if you add more and more hydrogen bonding, then what? More and more polar molecule, then this acetone will be taking a space and it will be hindering the hydrogen bonding. Okay, so D is the right answer. ठीक है, चलिए. Done all of you? Write D as the answer. So you will get very easy questions. ठीक है, ध्यान लगाइए बस थोड़ा सा, हड़बड़ाइए नहीं, इसमें लिखिए आप. Which of the following statement is correct regarding the solution of two components A and B exhibiting? Acha, one more thing. Positive deviation. Positive deviation से आपको सवाल जो घुमा फिरा के दे सकते हैं, ठीक है? They can give you like any example from which they can ask you about positive deviation. But negative deviation में they can't do that, okay? Because in negative deviation you have to know about the exact structure and if there will be new hydrogen bondings or new interaction that can be formed. So that is not going to be asked in your level except for the example of chloroform and acetone. Okay, ठीक है, Zarsh ने एक आंसर दिया है. Okay, let us see. Intermolecular attractive forces between A and BB are equal. तो ये तो नहीं होगा, ठीक है? जब भी अगर deviation हो रहा है तो आपके पास intermolecular force of attraction नहीं आएंगे. So this A is the case for ideal solution. A is the case for ideal. Okay, let us look at B. Intermolecular attractive forces between AA and BB are stronger than those between AB. Okay, डेल्टा एच में ऐसे ये दोनों ऑप्शन तो और होंगे भी नहीं, है ना? देखिए कितना आसान सवाल था. You don't even need to know what is the right answer. बस ये भी हो जाएगा आंसर आपका, ठीक है? बाकी सारे तो कट गए. Please write this question and write the answer. सबको समझ में आया बी क्यों होगा? Yes or no, please tell me.
Yes, sir.
So like the solubility part, na, it has many questions which are asked in NEET examination. Okay, so like this solubility, ideal, non-ideal, so it is one of the major portion that is there in like your NEET examination. Done all of you? Please tell me yes or no.
Yes, sir.
Write another one. Which of the following statement about the composition of vapor pressure over an ideal 1:1 molar mixture of benzene and toluene? Zarsh is giving me one answer. No, Zarsh नहीं. ये ध्यान रखिए जर्श, जो टोटल वेपर प्रेशर है ना वो इक्वल होगा, है ना? ऐसा नो जर्श?
Yes, sir.
अब जो कंट्रीब्यूशन उसमें किसका है उसके लिए आपको कुछ तो देखना पड़ेगा, है ना? सो फॉर द कंट्रीब्यूशन यू हैव टू लुक एट द, अच्छा ये बताइए वेपर प्रेशर के डेटा से यू हैव टू सी विच ऑफ द फॉलोइंग बेंजीन और टॉलुइन में से विच विल बी फॉर्मिंग मोर वेपर, विच विल बी फॉर्मिंग मोर वेपर. जो ज्यादा वेपर बनाएगा उसी का ज्यादा वेपर प्रेशर होगा. See, if you have pure benzene, then 12.8 pKa. If you have pure toluene, it is 3.85 pKa. So tell me, which is making more vapor, benzene or toluene? Which is making more vapor according to the data that is given here? Arey, what happened? नहीं आ रहा क्या? Hania, tell me, what do you think? Which will make more vapor, benzene or toluene?
Benzene.
Those who agree, please raise your hand. That benzene will make more vapor. No one. Okay. Raise your hand. देखिए, all of you see this. If I talk about the pressure of benzene, है ना, partial pressure of benzene, it will depend on partial pressure of benzene का PA ले लेते हैं, ठीक है? This is for benzene. Partial pressure of benzene, it is equal to P naught A chi A, and partial pressure of toluene will be equal to P naught of T into chi of T. अब देखिए, it is 1:1, right? Benzene और mole benzene में benzene and toluene, they are equal. They are what? They are having 1:1 as the molarity. Sorry, they are having equimolar concentration, है, जितना बेंजीन उतना ही टॉलुइन है. तो अब क्या होगा? This term is eliminated. That means the pressure due to benzene or the pressure due to toluene, it is not dependent on mole fraction because both of these are having same mole fraction, 0.5, 0.5. It will just depend on what? It will just depend on the, it will just depend on the pure vapor pressure. ठीक है? तो A will be the answer. I hope many of you are agreeing with this, that vapor pressure will contain higher percentage of benzene. All of you got this? Yes or no? Please tell me. Zarsh, Samaira, Nawal, Mazia, Khalil.
Yes, sir.
Right? Okay.
Okay, sir.
Chalo. Now let us type. How many of you know the process of distillation? All of you have heard about this word, right? Distillation, yes or no? Please tell me.
Yes, sir. Yes, sir.
Right? Distillation पता है सबको, right? Distillation पता है. So what happens in distillation? Can somebody tell me? Purification happens, right? There is a mixture, and the mixture is separated, right? Separation happens. You can say that's separation. Correct? Yes or no?
Yes.
Right? So essentially you have mixture, and then what happens? One of the component, so component 1, it evaporates, then we cool it, and then we get the liquid, right? Then we get the liquid. Now in distillation, you must know that boiling should take place, yes or no? Correct? We have to boil. अरे हाँ या ना बोलिए ना, distillation पहली बार सुन रहे हैं क्या आप लोग? Process बताएं distillation का.
Yes, sir.
Right? All of you know, right? The mixture, it has to be boiled. Zarsh, Samaira, Nawaya, Mazia, Minashi, tell me. Boiling should take place, yes or no?
Yes, sir.
Yes.
Right? Okay, fine. Boiling should take place. Now let us say you have two liquids. You have water. You have a particular solution in which you have water plus, let us say, what should I say? So बहुत ज़्यादा different. So oil ले लेते हैं, ठीक है? Let us take some type of oil. even though these two will not make a solution, फिर भी हम इसको ले लेते हैं. Water and oil are there in a mixture, and you have to separate them. Physically तो आप separate उसको कर नहीं सकते. Even though you can see a separation, you can't separate them, right? But when you are doing distillation, you're boiling it. You're boiling. What is the boiling point of H2O? 100 degrees Celsius, right? Yes or no? Please tell me.
Yeah.
For oil it is, बताइए कोई नंबर दे दीजिए. 100 डिग्री सेल्सियस तो नहीं होगा. Yes or no? It will be not 100 degrees Celsius. Yes or no?
Won't be.
Right? All of you agree with this?
Yes.
That for oil, है ना? Because the components are different, right? ना? In the intermolecular force of attraction in oil will be different that of water. So let us say that oil is greater than water. 200 degrees Celsius ले लेते हैं, ठीक है? 200 degrees Celsius. Okay. Now when we are boiling, which will boil off first, water or oil? Which will boil first?
Water.
Water, है ना? Water will boil first. Now please remember, if you remember latent heat of vaporization, it says that when you are boiling something and also giving more and more energy, then what happens? That energy is not consumed to increase the temperature, rather that the energy is used to convert liquid to vapor. Yes or no? All of you remember 9th class concept, latent heat?
Yes,
Yes
sir.
or no, guys?
Latent heat
Okay,
of
now
fusion and vaporization.
Vaporization, right? So please remember, you started heating, you have a mixture of water and oil, then you started mixing. Sorry, you started heating it. 10 degree, 20 degree, 30 degree, 40 degree, 50 degree, 60 degree, 70 degree, 80 degree, 90 degree, 100 degree Celsius. 100 degree Celsius में क्या हुआ? Water starts to boil. When water is boiling, the temperature is still 100 degrees Celsius. Now for 3 or 4 minutes, you will see that 100 degrees Celsius is there. That means water is getting evaporated, and then it is getting cooled, and it is getting filled in the container, right? So 100 degrees Celsius is maintained 3 to 4 minutes, and after, as soon as from 100 degrees Celsius it will go to 120 degrees Celsius, 110 degrees Celsius, then you will start to think, okay, fine, all the water has been boiled off and now the temperature is starting to increase. Yes or no? Please tell me. All the water will be boiled off as the temperature will go from 100 degrees Celsius to 110 degrees Celsius. Is that right? Yes or no? Yes or no? Please tell me. All the water has boiled off. If you see an increase in the temperature in the thermometer of distillation apparatus. अरे yes or no? I'm asking. नहीं समझ में आया क्या किसी को? Yes, Samaira, Nawal.
Yes.
Zarsh, Khalid.
Yes, sir.
Okay, fine. So what is the main point of difference between water and molecule? Now, what is the main principle of distillation? It is the difference in boiling point. Okay, so once you have boiled off all the water, you will stop the distillation. You have got the water in another container, you have got the oil in another container. Now, please tell me, if you have A and B liquids and this boiling point is 100 degrees Celsius and its boiling point is 110 degrees Celsius, will it be possible to filter them or distill them? Since they are having, so the boiling point is very near, right? 100 degrees Celsius and 110 degrees Celsius. Now, even at 100 degrees Celsius, a large number of B molecule will be evaporating, है ना? Because it is not that evaporation only happens at 100 degrees Celsius or 110 degrees Celsius for B. Even if you have 60 degrees Celsius of water, then also the evaporation will happen. It will not happen as the rate. I mean, rate of evaporation will not be as like of the 100 degrees Celsius or the boiling point, but still some evaporation will be happening. Similarly, when we are thinking that we are just boiling water, that means we are just converting water into vapors, a large amount of B molecule will also be getting converted into vapor, right? That is why if the boiling points are very near, we don't use this method. Now there comes another case in which we can't use the method for distillation. That is the case in which we have, for example, we had acetone and chloroform, if you remember, right? We had acetone and chloroform. Acetone, chloroform. Now, acetone was polar, chloroform was also polar, right? Acetone and chloroform was polar. When we mixed it, there is a completely new intermolecular force of attraction, which is hydrogen bonding, right? Now, hydrogen bonding is not present in individual acetone and individual chloroform, but it is present in the mixture. Now, if a mixture is having a new type of intermolecular force of attraction, that means this mixture will have a completely new one boiling point. So the temperature at which this mixture will boil, it will be not equal. It will be neither equal to the temperature of acetone, nor it will be equal to the temperature of chloroform. The whole mixture will boil at one particular temperature, right? At one particular temperature, because there is a completely new intermolecular force of attraction that is present here. And obviously, the mixture will boil at a higher boiling point than acetone and chloroform, because the intermolecular force of attraction is greater here, that is in hydrogen bonding. All of you understood this point? The boiling point will be higher of the mixture, yes or no? Please tell me.
Yes.
Yes, sir.
Yes.
Right. Now, similarly, when you look at ethanol and cyclohexane, so both, this is having hydrogen bond, right? This is having what? This is non-polar. Now, when we are going to mix this thing, then hydrogen bonding is what it is going to get decreased, right? So the temperature, now we are thinking that ethanol will boil. Ethanol के पास hydrogen bonding है ही नहीं है, right? The hydrogen bonding is not present. So for example, let us say ethanol boils at 80 degrees Celsius, है ना? Now when in the mixture, what will happen? The boiling point of ethanol will come down. Why? Because the hydrogen bonding, that means intermolecular force of attraction, also has come down. That is why what is going to happen? The boiling point will also come down. Yes or no? Please tell me. All of you got this point? है ना? So now we can see that there are kind of mixture which is having one singular boiling point, and also we can see that now one singular boiling point, और उसमें क्या दो cases बन रहे हैं. There are some mixtures which are having higher boiling point. There are some mixtures which are having lower boiling point. Now these mixtures which have a particular, or they boil at a constant temperature, जिसमें दो different temperatures में boil नहीं करते mixture, those are known as azeotrope. They are known as azeotropes. ठीक है? So we'll write the topic azeotrope, and then we will just write whatever the azeotrope is. Okay, we'll not explain once again. We'll write azeotropes. What we are writing? We are writing azeotropes. Okay, or constant boiling mixtures, or we are having what here? We are having constant boiling mixtures. Okay, constant boiling mixtures. Okay, so what are azeotropes? The constant boiling mixtures. So how can we define this? What is azeotrope? Azeotrope will be a mixture, right? A mixture or a solution which will show some kind of deviation. It can show both positive deviation or negative deviation. But the main point is that a solution which will boil at a constant temperature. Azeotropes are solutions which boil at constant temperature. Which boils at constant temperatures. Now there are two types of azeotropes. Azeotropes can be divided into two types. One is maximum boiling. Azeotrope, and the another one is minimum boiling azeotrope. Minimum boiling azeotrope. Okay, maximum boiling azeotrope, and then there is minimum boiling azeotrope. Okay. So in maximum boiling azeotrope, what is happening? The boiling point will be way higher than the boiling point will be way higher, right? The boiling point will be way higher. Now, if the boiling point is higher, that means intermolecular forces are strong. If the intermolecular forces are strong, that means it is showing what it is showing a negative deviation from Raoult's law. Okay, it is showing a negative deviation from Raoult's law. So we can write. So these are shown by. This is shown by solutions with negative deviation from Raoult's law. Okay, from Raoult's law. And this will be shown by solution with positive deviation from Raoult's law. Positive deviation from Raoult's law. Done all of you, Sanu, please tell me.
Yes, sir.
Done, sir.
Okay. Okay. So all of you have understood this point, right? I have not written any other point because you need to just remember maximum boiling, negative deviation, and minimum boiling will be showing positive deviation, right? Minimum boiling will be showing positive deviation. Okay. So I think Salman, you need today's notes now.
Yes, sir. Can you do that?
Okay, fine. I will do that. Okay, so see this portion of ideal, non-ideal, okay, and ideal, non-ideal, Raoult's law, it is complete. Okay, it is complete. Now, one more announcement is there. See what we are planning to do. I will be teaching you guys. Okay, now this batch I will be teaching you completely for NEET. Okay, this batch I will be teaching for NEET to theory part. Okay, all the theory parts. Now there will be one lecture each week, only for NEET. Only for NEET. Okay, so mainly the difference what we will be teaching in this week will be, so we have done all the theory portion, and we also worked for some problems in the class, but in the NEET, like, which is basically for NEET only, in that what we will be doing more questions. Okay, we'll be doing more questions that will be particularly focused on NEET examination and targeted on NEET examinations, right? And also we will be covering some miscellaneous topics, and there will be some parts, जैसे ना कुछ formulae होते हैं that you have to know for NEET examination, and then these formulas, these are not basically covered in your these are not basically covered in your CBSE examination, and you don't have to know those things. So we will be doing those things. Okay, important formula. So this is basically for NEET and JEE. Both will be covered in one lecture each week. Okay, that will be only for NEET, and there will be for JEE. In that we will be doing questions which are related to NEET and JEE and some miscellaneous concept. Okay, now this lecture, I will be not taking this lecture. Okay, but we have got IITB. IITB means IIT Bombay. So he's from IIT Bombay. He's a BTech from IIT Bombay. His name is Mohit Sayal sir. Okay, so Mohit sir will be taking this lecture on the special lecture that is there for NEET and JEE examinations. Okay, so he has, like, if you attend a few lectures, you will understand that how experienced he is. Okay, and he will be giving you more insights on how to solve questions and how are the miscellaneous topics and how are the questions framed, right? What are the important formulae, and he can also predict you some questions which can come in further NEET examination, and they will analyze the each and every chapter, and that lecture will be completely for NEET and JEE examinations. Okay, is that clear? Yes or no? Please tell me.
Yes, sir.
Darsh, Samaira. Okay, so I